So I'm going to show you my latest gizmo, and first I'll walk you through it. You may recognize some items from my previous videos. One of them is the AB Micrologix 1500. This PLC I hacked. This PLC comes with 12 relay type outputs. The first 4 relay outputs, I replace the relays by optocouplers so I can rapidly pulse them. And the reason of that is I wanted to control stepper motors with it. And this here is my custom made stepper motor driver. It's made out of 2 CMOS ICs. One of them is a quadruple XOR gate array, and another one is I think it's a D-type flip-flop or a JK type flip-flop double, and 4 MOSFET transistors, channel type N. And this is a stepper motor driver, a stepper motor with a couple 2 axes from a discarded DeskJet printer, and it comes I installed a home switch, so every time the axis is homed, it moves to the home position. And another item here is a pneumatic piston that I install over here, and this is to reject parts. So this pneumatic piston I attach to magnetic type plug switches, one for up and on the other side one for the bottom position of the piston. Of course, I have a pneumatic 5-way 2-position valve there, and the pressurized air is supplied by this homemade compressor. I made it out of a refrigerator compressor and a freon gas reservoir, a pressure switch here, a pressure gauge, and a solid state relay, and of course all the rest, the connections and all that. So there are about 4 bar of pressure there. I'll show you what the gauge is showing me. There's about almost it's actually 3.5 bar, and that's more than enough to drive the piston up. Just one piston, and that's more than enough. Another element is the inspection sensor from Banner. It's a PresencePlus sensor. It's actually a inspection camera that has a red LED flashlight, a magnifying glass lenses, and it comes with an I/O cable that I installed. You can see there it's actually I hacked this camera because I bought it. The output, the I/O, discrete I/O outputs were damaged. Only the trigger signal was working. So I installed 4 optocouplers inside. Actually, 3 optocouplers. So you can see that an LED is missing. That's because I had to use that, and these are twin color LEDs. So I'm using the pass and fail LED here to drive 2 optocouplers, and the ready signal here from the camera to drive a 3rd optocoupler. So I'm getting 3 outputs from the camera, and I go to the PLC, This is the cable, and a flash, the trigger signal, which triggers the snapshot. That's already that was working. This cable here is for the flashlight, so the camera triggers its flashlight. And here is an Ethernet port that you use to configure your inspection and grab the image from the camera, and it goes to the laptop. Now you can see there's a QuickPanel Junior monochrome 6 inches display from Total Control. I think now it's owned by Fanuc, but I'm using this. You can see it from my other videos that I'm reusing it. I built a special interface that plugs into the tool port of the panel. This cable here, this flat cable, it's a mini DIN 8-pin connector, and the panel supplies power to the interface, and it's on a max 232 IC chip, and it goes into the laptop. And I use Quick Designer to design the panel layout and all the tags and everything. So I actually made now right now it's not connected to the PLC, so this is the connected cable to the PLC. So the same cable that I used to program the PLC, I use it to interface to the panel. And I'm having it right here because I made some slight changes. Like I've added this here, which is a reset function that I want to add to the HMI. So I'm closing right now. I'm saving it first. I'm saving using Micrologix 500. I'm saving my project. Yep, I want to save the download data tables before saving. Yeah, I want to save that. Okay, I'm saving data files now, and I'm closing it. I'm closing also RS links because I'm going to be using the COM1 port, so I don't want to have any interference there. So I'm going to disconnect the PLC cable. That's the PLC cable, right? This one here. I'm going to connect it to the HMI. I hope you excuse me, but I'm using one hand only. The other hand I'm holding my smartphone to record the video. And here, this is the tool interface cable that I figured out myself, designed my own interface. And it's not the first time this is actually the third device of this sort that I made. I made one for Siemens Step 5 PLCs that compares TTY to RS-232, and also made one to connect to IDEC Micro 1 PLCs. So I'm pretty much experienced with interfacing with strange devices using level computers. Okay, so I'm going to open Quick Designer, which is the application that Total Control uses to design their HMIs. That's the tool, and here I'm going to open up my Vision demo and everything. All the drivers and Allen Bradley SLC DF1. That's actually a Micrologix, but this is the right driver. And if you want to configure port and all that, all you have to do is look up at your RS link settings and just set the speed at the same value you have on your DF1 connection. And the protocol, of course, you gotta set cyclic redundancy check and full duplex. Those are default values, so you just okay everything in case you don't connect. Okay, now I'm gonna add a tag first. So I'm gonna add a tag here. I'm gonna add one tag here. Yeah, it's gonna be B3. Oh, it's caps. Have to be caps. B3. colon 0/ 11. Okay. Close. I'm gonna open my panels here. Okay. So I'm gonna move this a little up here, and this also up here, and this also up here. I'm gonna move this indicators up and up. Okay, so now I'm going to add a button here. I think this just creates word buttons. I want to create a simple button. I'm going to put it here. I think actually here. Cancel. It's too big a button. I want to make it smaller. It have to be that big. Just have to be half of what it is. Like that. Yep. Move to. Okay. Push button. Clicking that, I'm gonna select the right tag. The tag that I just created, which is a reset signal for step 1. It's gonna be momentary. The legend is going to be reset underscore sequence. Okay. Okay with that. You okay that. You save it. Maybe the text is not right. I don't like the way it is. Legend. You don't need to use underscore. So I'm going to use just that. Yeah, that was wrong. Because I always tend to use underscore, but not this time because it's just a. Okay, save it. Save it, and then you got serial downloaded. It's going to download it to, and you can see the display is restarting. Hope you guys can see it. Still writing here, but it's going to restart anytime soon. The screen is scratched. This is actually a discarded HMI that I fixed. The backlight didn't work. So I just installed one of those LED stripes that you put on your car. There are 12 bolts, so I installed one here, and it works pretty well. See, it's all lit. There, you guys can see it. Yep. Okay, so now I can trigger camera. Camera is trigger. I can trigger off, trigger on the camera, reset the sequence. I can, and this is how I will reject the part. There's no part present, so I will reject it anyway. Okay, so once that is done, I'm going to close my Quick Designer here. I'm going to open the Banner application. That's the Banner application, and actually, just for the record, the compressor just started. So you can see the solid state relay lit on, and the pressure will rise up to 4+ bars. I mean bar. It's not purl. It's a unit. 4.5 bar. Okay. So this is the software you use for inspection. I'm using. I'm gonna first stop the inspection, and I'm gonna do a setup here. This is my test parts. These are rubber pieces. I think they came from the struts that I replaced on my car. Rubber washers or something. And this is different, of course. This is like measured type or something. I don't know where they came from. I think they're from the struts or something. I don't know about this one. But this one has got this kind of, I think it came from, it's already worn or something. So it's got this kind of ring. And I'm kind of much using it. So I'm going to show you two different types of inspections you can do here. This Banner, a vision sensor, it's a vision sensor, has different tools for inspection. So I'm just going to put a part here. I want to put my part here and for adjusting the inspection. That's good. That's going to be the good part. And I'm going to start with the vision detection there. So the part is detected. You can see. You can. It's now taking the snapshot. You can see my finger. I'm going to move my fingers inside. You can see my fingers there. I'm looking at them. That's the LEDs flashing, and well, so you're gonna go back to external and do next. There. It says you're gonna create a new inspection. No, I'm gonna modify an already existing inspection. You must reteach locate 1 and locate 2. Okay, I'm gonna show you how locations are. So what these are is I'm actually showing you that these are these crosshairs are lines to which the microcontroller looks up and looks for different grayscale patterns and threshold levels. So here, if you go to your selection, I'm actually using 4 of them. So I had location 1, locate 2, locate 3, and locate 4, measuring 1, measuring 2, and test the whole thing. So for instance, locate 2, locate 3, locate 2, 3, and 4. It goes like that. So what you will see is that you will see these are the bright and dark levels, and you can define a threshold. See here, you can smooth your signal. If you choose not to smooth it, it will look like that. If you choose to smooth it, you will have something like this. Smooth it. So I choose smoothing. Actually, 2 works better. But I'm going to change everything to smooth, non-smoothing. So you gotta play around with all these things. It's kind of fuzzy logic. Locate 2. It's kind of they can work on this because it's kind of a. You gotta open another window and thing. No, there. I'm gonna click on every other location thing and changing the smoothing. I'm doing that because this is quite normal with inspection systems. You get a trial and error, all the settings, till you get a efficiency percentage. I mean, you don't want to have false rejections, and you want to detect bad parts. So how efficient is your system depends on all the tweaking you do to all the parameters. In this case, the smoothing of the curve, the threshold levels, the intensity of the flashlight, all that, time lapse, whatever, you know. It's pretty much understanding all those and becoming an expert and all that. And of course, different. You have Cognex and all those other brands, or they may have different methods or different terminologies, but pretty much the same. And of course, I'm gonna have you look up at other things here, like the tolerance that you're gonna get is here. You define the tolerance, 20% tolerance, 20%. What it does, it just shows you the distance between this arrow, this triangle shapes, and that's pretty much what it does. So you do a quick teach. I'm gonna save the inspection to the camera. I'm gonna save it. I actually have 2 inspections. I'm gonna later show you the other inspection that I call geometry find. But first, I'm going to show you the first inspection that I loaded into the sensor. So you gotta have a look at that. You click start, and inspection starts. Okay. So now, if I click on the start button here, let me just